All right, how's everybody doing out there in Math Magic Land? This is Mr. Muscarella and my buddy L'Hopital. We're coming at you with our last example of indeterminate forms and L'Hopital's rule, or Bernoulli's rule, but we don't know whose rule it really is. But L'Hopital, his name's the one attached to it. So, remember indeterminate forms for limits are 0 over 0 or infinity over infinity. The other indeterminate forms are one of these guys that might have to be algebraically manipulated to become 0 over 0 or infinity over infinity. Now in this particular example, we're going to take a look at the extended mean value theorem. Alright, so we've got a theorem and it says if f and g are continuous on the closed interval AB and f and g are differentiable on the open interval AB such that g prime of x equals 0, or does not equal 0 for any x in the open interval, then there exists some point C in that open interval such that this formula is true. So let's take a look at the conditions here, because you always want to analyze conditions, because if you ever have to prove this, you're going to have to prove each one of the conditions here are true. So let's see, f and g are continuous on the closed interval. That's going to be one of the conditions. F and g are differentiable on that open interval. That's a second condition. And then the third condition is this piece right here. The derivative of our g function can't be 0. Why? Because look what's in the denominator here. The derivative of something can't be 0 in the denominator because something over 0 is bad. We don't like that in math. So let's go ahead and take a look at our example here. In our example, what we're going to do is see if the extended mean value theorem applies for these two functions here. We're going to have f of x be sine of x and g of x be cosine of x. Our closed interval is from 0 to pi over 2. So again, let's take a look at our conditions. Are f and g continuous? Well, yes, sine of x and cosine of x are definitely continuous on 0 to pi over 2. Are they differentiable everywhere in 0 to pi over 2? Yes. Now, g prime of x, so what I want to do real quickly is then take a look at, so this condition was met, that was okay. So to see if our third condition is met, g prime of x not equal 0, we're going to differentiate each one of these, f and g, to come up with our derivatives. Now g prime of x is negative sine of x, which of course is not equal to 0 anywhere from 0 to pi over 2. So since that is the case, the extended mean value theorem applies. So what we're going to do then, f prime of c over g prime of c, what we're going to do is first take the derivative of each one of those. So f prime of c, that's our cosine function because f of x was sine of x. So we're going to have cosine of x over negative sine of x. That's going to be equal to, now f of b. So I'm going to have, my b is pi over 2, so I'm going to have f of pi over 2 minus f of 0, all of that over f of, or g of pi over 2 minus g of 0. And f and g are your sine and cosine functions. When you evaluate that, so we're going to kind of keep this organized this way, cosine over negative sine, I'm going to kind of rewrite this piece right here as just negative cotangent of x. Now when I evaluate the right hand side, I'm going to have 1 minus 0 over 0 minus 1, which gives me a grand total, when I clean that up, of just negative 1. So I'm going to have negative cotangent of x equals negative 1. Well, I can get rid of the negatives. That's kind of nice. So that'll just give me cotangent of x equals 1. But cotangent of x, most people aren't as familiar with that. So we're going to rewrite that to be its reciprocal function. The reciprocal function of cotangent is 1 over tangent. So 1 over tangent of x. Now if I take the reciprocal of each one of these, because that's kind of where I'm going with this, reciprocal of, if I flip each side, I'll still have tangent of x, but then when I flip 1, I still get 1. So now I got to figure out what value, so let me kind of go over here for a second, what is this c value between 0 and pi over 2 that gives me a value of just 1. So in order to figure that out, we have to use inverse trig, so c is going to be equal to the arctangent of 1. Now remember your domain restriction. Inverse tangent of 1, you should remember that that is just going to be pi over 4. So C is going to have the value of pi over 4 in the interval 0 to pi over 2. So that's it for this. That's all you have to do. But you have to just make sure you take your time and take the derivative of your two functions f and g after you've already concluded that the three conditions for the extended mean value theorem apply. All right, thanks for watching this video, and I will see you guys soon. Peace out.